Well, welcome to our second lesson on linear equations. In this lesson, we're going to be working on reviewing some of our linear equations. You should be familiar already with your standard form, point-slope form, and slope-intercept forms of linear equations. Remember, because they're linear, all of them graph as straight lines. And you should be able to determine whether lines are parallel or perpendicular or neither. And then we'll also be writing equations of lines that are parallel or perpendicular to a given line. So first off, we need to talk about slope and what that is. And the slope of a line is just basically the ratio of a vertical change, which is our y variable, divided by a horizontal change, which is the x variable. It's the rise over the run, and that's a change over any 2 points on the line. We calculate the slope using the formula y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are just points on the line. All right, so to find the slope of a line, our first example, we're given 2 points. We're going to use our formula, which is y2 minus y1 over x2 minus x1. It does not matter which one you assign x1, y1 and x2, y2. I usually just do the first one as x1, y1, and the second one is x2, y2. Just remember that each ordered pair has an x and a y. It's not x1, x2, it's x1, y1. So just keep that straight. And so in this example, we're taking y2 is 3 minus y1, which is negative 1, divided by x1, which is negative 5, minus 2. So 3 minus a minus 1 is 3 plus 1, which gives us a 4. Negative 5 minus 2 is negative 7, giving us a slope of negative 4 over 7. So here are your 3 forms of linear equations. The first one is point-slope form. Y minus y1 equals mx minus x1, where you have a point, x1, y1. So these two will be replaced with numbers where those are just an ordered pair. It's just a point that's on the line, and you'll need to know your slope as well. This y and this x here stay in your equation. So that's probably the most common mistake students make, is they don't understand the difference between the y variable and the y1, which is actually a coordinate of a point. So you need the slope and you need a point, which is why it's called the point-slope form. The slope-intercept form, you have the slope, which is m, and this b, which is the y-intercept. Now remember from our last video, the y-intercept is where it crosses the y-axis, and it crosses the y-axis when x is 0. So if you think about just letting this be 0, y equals b would give us where it's going to cross that y-axis. Standard form is ax plus by equal to c, where a, b, and c are just numbers, and they aren't anything specific. It's not the slope, it's not an intercept, they're just whatever numbers work out when you put it in that form. Excuse me. So here's an example. It says write the equation of a line whose slope is negative 3 and it goes through the point 4a, and we want that in slope-intercept form. So we want it in y equals mx plus b form. But I'm not going to start with that form because I'm given the slope and a point. I'm going to start with point-slope form. So then I'm going to substitute the things that I know. Okay, I know that the slope is 3, so instead of m, I'm going to put in negative 3. And then instead of x, I'm going to put in 4 for x1. For y1, I'm going to put in 8. Okay, so these are the two that stay. This x and this y stay there. y1 and x1 with the subscripts are the ones you replace. And now to get that thing in slope-intercept form, we need to solve it for y. So we need to distribute the 3 through the parentheses, and we'll get negative 3x plus 12. Watch your signs there. And then adding 8 to both sides, we get y equals negative 3x plus 20. So there we have the equation in slope-intercept form of the line whose slope is negative 3 and it passes through the point 48. In this example, we're going to find the equation of a line that goes through those 2 points, and we want it in slope-intercept form. So first of all, we need to calculate the slope, which is the rise over the run, change in the y variables, the vertical change over horizontal change. Not going to spend a lot of time on that, so you should be able to calculate that. That should be a review from Algebra 1. Then what we're going to do is we're going to go ahead and we're going to put it into our point slope form. Now it does not matter which of the 2 points you use. Now that we know the slope, we can pick either one. So in the first example I'm going to do here, I'm going to use the point 3, 4. So it's going to be y minus y1 is 4 is equal to our slope that we just calculated times x minus x1 is 3. And then we want that in slope-intercept form, which means distribute your 7/3, and then you're going to add 4 to both sides, and you get y equals 7/3 x plus 3. Now over here on the right, I'm just going to show you that it really doesn't matter if I had picked this point. Substituting that in for your x1 and your y1, you end up getting the exact same equation. So it really doesn't matter. It's completely random. Here's another example. Find the equation of the line with a slope -6 that goes through this point. We want this one in standard form. So we have the slope and we have a point. So again, using point slope form, we're going to do y minus y1 is -2 equal to our slope times x minus x1. Distribute your 6 through the parentheses, a minus 6x, and then that becomes a plus 6 over 4. Reducing that, you get 3 over 2. And then subtracting 2 from both sides. Where did that go? We're going to put this in standard form. Oh, I see what we're doing. So in standard form, what we're going to do is get rid of this fraction. So this is what we're doing over here. So I went from this side to this side. If I multiply, because I have a fraction over here, if I multiply my entire equation by 2, that'll get rid of my fractions. So I'm going to multiply the left side by 2, multiply the right side by 2, and that's what I've done over here. So just so you know what's going on. When I multiply the left side by 2, I get 2y plus 4. Multiply the right side by 2, our fraction goes away, which was our goal. And then what we need to do is bring the x term over, so we're going to add 12x to both sides, and we're going to subtract 4 from both sides. We're going to get 12x plus 2y is equal to -1. So that is in standard form. A little bit of a review about vertical and horizontal lines. They don't look the same. Their equations don't look the same as anything that we've talked about, point slope or slope intercept or any of those forms. They're pretty unique. So the equation of a vertical line is x equal to c, where c is just a constant, and a constant is just a number. So if you have an equation where like x equals 1, x equals 5, x equals -7, those all graph as vertical lines, okay? And the slope of a vertical line is undefined. There isn't a slope. It does not exist because we end up dividing by 0 in our equation. So you just need to remember what the vertical line equation looks like. A horizontal line is y equal to a number, and the slope of a horizontal line is 0. Okay, that is defined. 0 is a legitimate slope. So we end up getting, for our rise over our run, it doesn't rise vertically. We have a 0 rise and whatever run we have, so 0 over anything is 0. So vertical line, undefined slope, horizontal line, 0 slope. Find the equation of a line passing through these 2 points. Again, we're going to use our slope formula. Y minus y, so 4 minus a minus 3 is 4 plus 3 over 1 minus 1. And when we're dividing by 0, that tells us it's undefined. So now we know it's a vertical line, x equal to a number, and x equals, in both of these points, x equals 1. So if you plug these points into your slope formula, you'll find out you get a 0 in the denominator, which you know is undefined. That tells you it's vertical. And then look at what the x-coordinate is of the points. Parallel and perpendicular lines. Parallel lines have the same slope. Okay, they're this exact same number. So if you have 2 lines and their slopes are the same, that tells you they're parallel, they never intersect. Perpendicular lines have negative reciprocal slopes or opposite reciprocal slopes. For example, 2 and -1/2 would be perpendicular slopes. We can also show that the lines are perpendicular if we multiply, take the product of the 2 slopes, and we get -1. It's another way of showing that lines are perpendicular. So here's an example. Let's decide whether or not these 2 lines, are they parallel, are they perpendicular, or is it neither? So the first thing you want to do is solve for y. If you put it in slope-intercept form, it's very easy to tell whether they're parallel, perpendicular, or neither. If it's solved for y, the number in front of x is the slope, right? Y equals mx plus b, so m is negative 4/3. So let's solve this one for y. So we're going to subtract 3x from both sides and then divide each term by negative 4. And a negative 3 divided by negative 4 is a positive 3/4. So if we look at our slopes, we have negative 4/3 and positive 3/4. They have opposite signs. They are reciprocals. So therefore, we know that these two lines are perpendicular. So we can compare those two slopes, negative 4/3, positive 3/4, multiply them together, we get negative 1, and that tells us that the answer to our question is they are perpendicular. Write the equation of a line parallel to this line that goes through this point. So we're going to start with that line, okay, and it's going to go through this point. So first of all, we need to figure out what is the slope of the line that we're starting with. So we're going to solve it for y, so subtract 5x from both sides. And I see we have an error right here, so make sure you put in here a little negative sign for me. I see that's missing. It should be a negative 5x. Okay. So from that point, y equals, dividing by 3, so we got it in the second point, we're missing it here. Y equals negative 5/3 x plus 1/3. So that's the equation of this line just written in slope-intercept form. Now what we're going to do is we're going to plug in the points 3 and 5. Okay, so using y point slope form, y minus y1 equals this one, we want it to be parallel, so it's the same slope. Slope times x minus x1, so x1 is 3. And it doesn't tell us what form we want this in, so we're just going to distribute this. We get y minus 5 equals negative 5/3 x plus 5. And then add 5 to both sides. Y equals negative 5/3 plus 10. This is in slope-intercept form. Find the equation of the line perpendicular to this one passing through that point. Same exact process as the example above. Solve this for y. Okay. Plug in your point using point slope form and then write it in slope-intercept form. So I'm going to just zip through this one fairly quickly, subtracting 5x from both sides, dividing by negative 3, plugging in your point negative 4, 1, and solving for y. Getting like denominators here, we end up with y equals negative 3/5 x minus 7/5. Here is your lesson check. Please do these 4 problems and bring them to class tomorrow. See you next time.